Hello, good day. Welcome to tonight's lecture. We're going to look at Unit 5 of the lecture, which we're going to look at simulating CNC milling. We're going to use the software to help us understand how we can use the codes to understand the CNC milling commands. So we're going to start by considering some examples. The first example that we're going to look at is the example in this view. As we're going to create these slots, which is within the block, and we have the block dimensioned as shown here. Now we're going to use the coordinate positions here by assigning x and y coordinate as the vertical and the horizontal coordinates as x and y and then x. So we're going to use that just like you see here. So our y is actually going this way, x is coming on this side. Now when we look at the plan view, then we will look at it from this way, so that our y is essentially this and our x is that. Okay, so we're going to look at this in terms of trying to program the GNM codes to actually come out with this piece of profile. So the example 1 reads that we want to look at the Cartesian coordinate system and the absolute coordinate system. But this one we're just going to look at the absolute coordinate programming on this particular example. So we have a figure here that we want to eventually create using the CNC GNM codes. So if you look at the piece here, we will have to make the tool start at this position, and then we go through the profiling by going in this direction here. We follow through to this position, so the first position here, the second position, and then we have the third position of the tool here, and then the fourth position of the tool, and then finally the tool will come home back to the first position, and then it will create this profile. So if we are trying to write a program to generate this is how we're going to start it. First, we will have to define the workpiece. So the workpiece size is x5, y4, z1. So it means this dimensions, the thickness of this block is 1 inch, the width is 5, and then the height is actually or the breadth, if you like, is 4 in the y direction. So having this, and then knowing the tool that we want to use to create this profile, we put the tool size there. So first, what we need to write in the first line of the program is the workpiece size. We have to define the blank, and then we define the tool size. So here is workpiece size, then we have column, then we define it in terms of the axis x5, y4, z1. Then we have the tool, which we will have to state the tool number. So tool number 3, and then we have to give the dimensions and some description of the tool. So tool number 3 is going to be a 3/8" end mill, and the to start position is going to be x equals 0, y equals 0, and z equals 1 relative to the workpiece. So this position clearly shows, if I do it in a three-dimensional or isometric representation, it's going to be at the top edge here, where you have s equals 0, y equals 0, and then z is equal to 1. So that's where the 2 is starting from. Okay, so when you want to write any program, you need a work, that is, you need these three. You need to specify the blank, which is step 1, the 2, and then the to start position. So to initialize the program, you need to bring this percentage sign to initialize the program. And then the first line that you need to write in this column is the program number. That is, you have to identify the program by a name or a number that you save the program as. So this is saying program number 1001. Right. Then we come to the first line of the program, and as I said previously when we were looking at the fundamentals, we said that the line command is giving a notation as n, and then you have either a 5 series or you can have a 1 series, which will just start 1, 2, 3. But in this case, we are going to use a 5 series numbering. So this actually shows a line number 1, which is showing the N5, but it's line number 1. And then we will have line number 10, which is the second one. So I'll just quickly do a simple edit here for us to go on, because this is supposed to be line number 10. So this was supposed to, sorry, yeah, okay, so this is it. So this is line number 5, this is line number 10, which is the next line. So the first line, we need to show that whether we are programming in absolute coordinates, and then whether we are programming in inches, that is the unit, or in metric. So J90 means we are programming absolute coordinates, and then we are programming in inches. Okay, so then the next line is M06 command, which is saying that we should change the 2, whatever the 2 is in the program or on the CNC machine, to number 3, T3, just to synchronize with the 2 that we are going to use for this program. So change to that is M06. It's a 2 change command to T3. Okay, now after we change the 2, then we set the spindle rotating in the clockwise direction, M03, and then we give it a speed. We give it a speed, and that speed is given as 1200 RPM. Okay, so the X means speed, and that is 1200 RPM. Okay, then we can give an N. Then we can give an N20 command. Sorry, we can give the next line, which is line number 20. Now line number 20 gives us a rapid movement, which is a G00 command, which is commanding the 2 to move from wherever the 2 is to this position, and it's a rapid movement. So we command the 2 to move into position x1, y1. x1, y1 from our drawing will be this point that I've indicated on the drawing, x1, y1, at the central point here, shown by this pointer here. X1, y1 is going to be central. X1, y1, we will just be grazing on the top of the block. We have not done any feed yet. Then x1, y1 means it is going to have x1, y1, and then it will pick the coordinate position, which is going to be the x0, sorry, it's going to be the z1. Now when we are programming, we will have to set, when we are programming, we will have to set the coordinate position, the coordinate start position on top of the workpiece. So I'm just going to show you how we will set that. So the xy coordinate position will be set on top of the workpiece like that. Okay, so this will be x, this will be y, this will be x, then this will be z. Okay, so the z equals 1 and then x equals 0 is just 1 unit above the workpiece. So the 2 start position, if let's say this is the 2, I'm just going to use a different marker to draw the 2. If let's say this is the 2 start position is going to be somewhere here. Okay, that is 1 unit from the top position. So x1, y1 here, x0, y0, z1 is going to show 1 unit away from the top face. So when we give it a rapid go to x1, y1, it is also going to carry the last z coordinate, which is the z1. So x1, y1, z1, it's going to move all the way up to the position which is x1, y1 here, but it will be hovering on top. It will still be at the top because the z position hasn't changed. Then we move it further down to z 0.125, which is a little down. Okay, now the principle is that all the z movements, the positive z movements, are not feeding move or cutting move. They don't cut the material. All positive z movements are on top of the workpiece. So meaning if we go 0.125, we're just coming closer to the workpiece, but we are not feeding into the work. So we'll be somewhere just hovering on top of the workpiece at this position. Now we then apply a linear feed move, which is J01. Now z value changes to negative, meaning now once we go negative, it means we are now cutting through the block. So z minus 0.125 means we are cutting through the block to a depth of minus 125.125 of an inch at a feed rate of 5 inches per minute. Okay, now we cut through, so the mill will just sink through at a feed rate of 5 inches per minute into the block. Then the next line, N35, is the next line number. We are supposed to move the cutter to move at that depth to x equals 4. So the cutter will move along this line all the way to where x is equal to 4, and it will come to this position at the feed rate of 20 inches per minute. Then the next line, which is y equals 3, the cutter will move from here all the way up to y is equal to 3 here, because y is equal to 3. So the next line, the cutter will move up to this place. because it is still using the linear feed Gin01, the command will still be active because we say it's a modal command. It can only be cancelled if you have given another Gin command. So the next line will now be x equals 1. So the cutter will then move all the way from that position to where x is equal to 1. That is, to move all the way to this point where x equals 1, because the y hasn't changed. In this position, x equals 1, y will still be equal to 3. Okay, that's what we should take note. In this position where y is equal to 3, x will still be equal to 4. So it means x has not changed. But because they have not changed, we can choose to leave it. That's why we just put y3, x1. Then from 4, x equals 1, the 2 will then move all the way down back to a starting position to create the profile. And that is, it will move back to y1. But in this case, x will then be x1, because the x has not changed. Okay, so after it is done, we move the 2, a rapid movement. This is not a cutting move. So Gin00 is a rapid feed to z equals 1. So it moves the 2 up z equals 1, because we say all the positive z movements are away from the block surface. So that is z equals 1. Then we have the final movement, which is n60, which is moving the 2 x0 y0. So x0 y0 mean at this point, if it goes to z1, it means x is 1, y is also 1. But when it comes here, then x will now change back to the home position, which is right on top of the z, which is x0 y0 and then z1. Then the 2 moves into position. Then finally we turn the spindle off, and then we end the program with the M30 command. So in a nutshell, this is how this program will run. Now I want us to watch a simulation of this program very quickly using the software. So we basically go to the software, which is this, which is showing the CAD Viewer 10, CAD Viewer Mail. Basically, to turn it on, we just select the CAD Viewer software and run it. So now I'm going to put some file, that is example 1, it's the text file. Example 1, the text file, I open it, then I copy the program in the notepad. Now I'm going back to create a new, and I use the standard Gin code. Then I put the program here, down here. I just do Control V and I paste it. So if I scroll, the program is here. But if I want to use the software, first I have to rebuild the program, because I've just copied and pasted. So I just do running, I'll come to running and say rebuild. Then it will start simulating the program. First line, it will see it said no tool found. So do we want to define the tool? Yes, we have a tool inside, so we set the tool. The tool is 3/8 of an inch, so we have to give the size, the diameter. It is an end mill, so 3/8 of an inch. If you can bear me with the calculation, 3/8 of an inch is going to be 0. You have 0.3 Okay, let's do it quickly with some assistance, just using the calculator to do it. 3 by 8.375. Okay, so we put the size there. The height of the two, we can just give it maybe 1 inch in height, or maybe 2 inches, just for the sake of that. Okay, so the two ID, in this case our two number is two number 3, so we just give it an ID 3, and then we click OK. Okay, then it comes and find the 2 and asks us, do we want this new 2 to be defined? Then we say yes. Then we will just say it should assign that 2 to T3. So we say OK. Now it has to find the stock. That's the blank that we are going to use to machine, which is the workpiece size. So we said, do we want to define the stock? We say yes. We define the stock, and from our coordinates, our length is going to be 5, our width is going to be 4, and this is going to be 1. Okay, and our origin position is going to be 0, 0, 0, 0, and then the Z position is going to be 1 as our origin position. Okay, then we can OK it. When we OK it, it's run it so quickly that you didn't see anything. But I'm going to change the dwell time so that you can see how it's really. So if you want to change the dwell time, go to setup, and then you just change the dwell time here. You want to give it an elaborate dwell time, let's say 300 milliseconds, and then we say OK. So I just want to run the program again for you to see. So once I click run, you see that, yeah, even this, it's so very quick. I'll just change the dwell time again to about 600 milliseconds. Now let's do again. So you see the 2 move into position, and then it moves and moves that way. So if we want to do a trace of the program, I'll just do a quick trace of the program. So we go back and let's see a trace of the program. I trace forward step 1. The 2 moves into this position, and it's x0, y0, and 1.00. So you see that's where the 2 is sitting from this side. Now the 2 then moves to a position x1, y1, z1, and you can see that. Then I move on next, the 2 advance down to x1, y1, z 0.125. It's not feeding yet. Now the next trace means it should advance to negative 0.125. So it starts feeding into the workspace. Now the next trace forward is the 2 should move to x4 with so y1 and then z minus 25. So there's 2 move this way to that position. And then I trace next, the 2 has to move to x4, and then we have y3 position. I trace next, the 2 move from y3 position back down to x equals 1 position. And I trace next, the 2 move from y equals 3 back to y equals 1 position. And you can see the movement down here. If you check the program, you can see that movement being displayed down here. So I just want to show you that. so that you can see we are now at that position. So we trace next is a rapid movement to position, so the tool advances up z equals 1, and it does another rapid movement back to x0, y0, and then z, so z equals 1. So it moves back here, and then that is the end of the tool path, and that's M05, and then M30 means program end. Okay, so we can, this is the simulation. We can simply save it. If we've finished, we can save it. Now after you've run the simulation and you check the file, you'll notice that the software has added some information to your text. That's a tool. You have just given a tool with some coordinate values there on the stock. The block, it just assigns its own coordinate system, and it has a color matching of 255 255. This is from the software, so that shouldn't be an issue for you. But your program starts with a workpiece size and all that. So that represents the first example. Okay, now we want to look at the next example. This is the next example 2, which is looking at this profile. We want to mail this profile. That is, we have some profile which goes in and out there, but it's all in a slot mail. So we want to set a tool, advance the tool around this in some fashion to really create this slot that you have there. Okay, so now let's look at how this example is dealt with. So just by the program, we simply, let me just put it in this way. Now let's look at this example. Now we have this as a block. So first we have to give the dimensions, the workpiece size. In this case we are using a very similar workpiece size, x4, x5, y4, and z1 as the basic dimensions. And then we have a new tool T2, which is a different size, 1/4 of an inch end mill. And the tool start position is x0, y0, z1. Now we initiate the program by bringing this percentage sign here, as you can see. Then we put the column and then write the program number. So the program number can be any number. In this case we are just numbering it 1002. Then our first program line is basically this line, which is N5. Again, we assign we try to put the coordinate settings. There's a work coordinate settings saying that we are programming in absolute, and we are using inch units, which is a J20. Now we set the tool, that is an M06, which is selecting tool selection or a tool change to tool number 2, which is named as T2 from the information here. So we have T2. Then we turn the spindle on in the clockwise at a speed of 1200 RPM. We give a rapid movement of the tool from wherever the position is. The position is at X0, Y0, and then Z1. So we are setting the coordinate position here. Okay, now relative to the drawing, this is X0, Y0, and then Z1 at this point here. But when we start programming from here, a movement up in the Z will start a 0 from the Z. The Z will start a 0 from here again. But knowing that in the system, the workpiece is actually at the work coordinate system is here. and then the program coordinate system is up here. So we have z is equal to 1 actually here. However, when we are programming, we program from this point and let the system assume that this is our 0 position for both x, y, and then z. So this is the position that we are going to program from. Again, we give a z 0.125 just like the first program, and then we give it a feed of minus 0.125 at the feed rate of that. Then we move to x4 at a feed rate of 10 inches per minute, and then we go to y3 at a speed at the same speed anyway. Then we come to x1 y1. So from y3 we are coming, this is y3 position, we come from x1 y1, so we'll be coming this way. So the two's direction will be from this side towards this side here, okay, and then we go up this way towards up here that way, and then we come this way. So we're coming down that way. Okay, so just to illustrate that. Okay, right, so that means we are now in this position, that is we're coming from here down to x1 y1, that is x1 y1. Then we are from here, we move to y3, so the two will then move this way to y3, and then the two will move to s4 y1. s4 y1 is going to be this way, s4 y1 that way. Okay, and then it's then moves s4 y1 here, and then it goes, it rapids to this position. Okay, and then it rapids out, and then we are through with the work. Okay, so let's see how this will finally be traced. Let's go through the program again. We have from this side to x4, so we cover this side. Okay, then we go to y3 this way. Then we go to x4, then we go to x1 y1, so we come across to this position. Okay, then we go to x3, we go to s1 y1, then we come to y3, that position, and then we come to x4 y1, which is that, and then we wrap it out. So actually it means that this part of the figure is not supposed to have shown anything up here. Okay, so we will just make the necessary adjustment. It means this is going to show something like this as a solid block. So this, it means this portion is not cut through. Okay, so it is just across that way. So let's see how the simulation turns out, then it will help inform us. Okay, so we keep that, and then we go to the software. So we can now create a new file. We will not rename this. It's a standard G code. We will not save this. We say no. Then we try to find the text that is we try to find a new example to this one. We just copy that into the program. And then we try to rebuild it. So we go to running and we say rebuild. It starts searching for the 2, and this time they don't find the 2. It said, do you want it to be defined? Yes. Then we define the 2. Our 2 ID is T2, and our 2 size is 0.25. It's a quarter of an inch, and then it's an end mill. So let's say assume it's a flat end mill, and then we OK it. The 2 diameter, there's some problem there, so we just change it. It's 0.25, not 0.25. So we just OK it, and then he wants us to the new 2 to be defined. We say yes. Now the 2 that we want to define is the one T2. We can define it here as an end mill. It's an end mill, and then we say OK. And then we want to define the stock. We say yes. Now we define the stock is 0. The origin will be 001. And then we have the size as 541. We have the size as 541 here. And then we OK it again. Then we watch the movement. Okay, so this is what we wanted to create. So if you look at it, if I want to trace back for you to see the first movement, the 2 start position is x0, y0, z1, so the 2 is there. We trace forward 1, then it comes to the chain 2 and all that, so it looks for the next movement for the G code G00 x1 y1. It moves into position x1 y1. The Z position will still be 1, so it will be up there just hovering that position. Then next it advances down Z 0.125, just like the first example. Then it starts feeding a G01 command, and the Z is negative. Then it moves this way. You have an X4 at the feed rate of 10 inches per minute, and then the next is a Y3, and then the next is an X1 Y1, so it comes this way. The next move is a Y3. The next move is an X4 Y4. And then finally the 2 does a rapid out Z1 and then to the home position. Okay, so that ends that simulation 2, and that's 1, 2 is done. So we move on to look at the next, which is the next example. Which is example 3, which is looking at this, which is using a G02 command to create all these radial arc. So if you look at the steps, we're going to just do a run through this, and then we'll look at the program. So this is the image that we want to generate with the software, like with the CNC mill. Now this is the start position for the 2, and then the 2 will have to start here and move into that position, or else the 2 can start here depending on what the program is really looking at. And so we have the 2 start position here. It moves up this way. It creates this arc in this fashion. It continues and creates this arc further this way, in this direction, and then creates this next arc, and then does a linear feed down like that, and starts another arc creation from here in the counterclockwise direction, and create this arc here, and then finally generate this arc. Okay, or it could start an arc creation, generate this arc, and then join it to that. So we want to know how this program is written to generate this arc that we have seen, right? Okay, so just going to the program very shortly. We have this as the example. So now we have the coordinates on the program. Just to do a quick correction here to this line number, which is supposed to be on the next line. So that's here. So now we have this as our example 3. Now the first is to give the workpiece size, and that is still using the same block S5, Y4, Z1. And then we have the number 2, which is a slot mill, is 0.25 of an inch in diameter, and the 2 start position X0, Y0, Z1 relative to the workpiece. So the first command line we give and initialize the program, and then give the program number. This is 1003. Now we show that we are programming in absolute coordinates inches. We change our 2 to number 2, T2. We turn the spindle on at the speed of 1200 RPM. We give a rapid movement, a rapid go to position the 2, and we give a rapid go to position the 2 at this position, which is X.5, Y.5 here. So the 2 sits here. Then we give a Z 0.25. So we advance the 2 a little bit closer to the workpiece, but because the Z is still positive, it is not doing any cutting. Before it starts to feed into the work at minus 0.25 in depth, so it feed down minus 2.25 at a feed rate of 5 inches per minute. Then it does a Gen 02 X 1.5 Y 1.5, and then we have the radius as giving us the center of the arc as giving us I1 J0. Now let's look at it. The end position of the arc is here, X 1.5 and then Y 1.5 from here. So the center of this arc, you can easily find that, and then you will notice that to find that center coordinate, you notice that there was no change in the you can see there is a change here. There is no change in the value of the start position and then the center position. If you take the center position, the 2 center position has this one is the center position, which is X 1.5. Okay, this is 1.5 and then Y 0.5. Okay, and here it's going to give you the start position. The X is still 1.5 up here. So if you take the center position and then the end position here, and you want to work out the radius, the two start position gives you a situation where the I is equal to 0 and then the j is equal to -1. Okay, because if you look at the two start position here, the j is going to give you -1. Sorry, I'm looking at the wrong one. Sorry, the I is equal to 1 and then j is equal to 0. Please, we are here. So that is I1 and j0. If you look at this, the x position changed by 1 unit. So you notice the I1 from the start position, and then the x position did not change, the y position did not change, so the j is showing 0 at a feed of 10 inches. Then it does here an x 2.5 and then the y 2.5. So a 2.5 position here, and then an x 2.5. So the 2 will come here. So the x 2.5 position. So the 2 will first complete this one, this arc. Okay, and because it's giving it as an R, the R means that this arc is exactly a quarter of a quadrant. It's not a full circle. So the radius is 1. So it will generate just a quarter of an arc like that. Unlike the I and the J's, which you can generate a full circle for you. So it means we then come here. Then we move on to x 3.5 and then y 1.5, which is down here. So it moves on to this position, and this time it uses an ij. If you look at this, is the start position, and then the 2 will then move here. Now the center position is here, which is 2.5 and then 1.5. So you notice that there was no change in the y, though there is a change in the x. So the change in the x, you can really see that change in the x, because it's now moved to 3.5. So the change is actually registered. So let's see, if you move from here, x is equal to from 2.5. now x is now 3.5, y is equal to 1.5. that is, we are here. So now let's look at the 2 start position here and then the center. So there was no change in the x, and then there was a change in the y. So I0 j -1. So we drop here, and then it continues with the same j02, and that's an x 4.5 and a y 0.5. So the 2 finds its center down here at this point, and then do an arc move this way to this point. Okay, now the program moves on at this point where we were in the other figure, and then it does a J01 y 1.5. so that's just a linear feed upwards 1.5 to this position, which is this, and then it does a J03, which is a counterclockwise movement to this position at x 3.5 and then y 2.5. so you notice that it's still y 2.5 down here, because it's doing a counterclockwise movement that way. And then it does an x 2.5 y 3.5 is also a counterclockwise movement, so it moves to x 2.5, which is here, and then y 3.5, which is going to be up here somewhere. Okay, so it means that the two will then move up to this point, which is that, and then it does another x 1.5, another counterclockwise x 1.5 to y 2.5 at a radius of 1, because it's doing a half quadrant, a full quarter of a circle, so it does the quadrant here up to this point, and then it moves x 0.5 to y 1.5. So x 0.5 to y 1.5 is here. So it does another G03. Once the G03 command has been issued, it remains until it is cancelled by another command. So that is x 0.5 y 1.5 up to this point. And if you look at the center of this particular arc, you notice that the x coordinate did not change. The y coordinate actually changed from 2.5 to 1.5, so the difference is -1, and then the I is 0. So the G01 feed, linear feed right down to y equals 0.5, so it will just feed down to this point. Okay, and then that means the arc is complete, because this is the first one that's done. Then the arc is complete, and the tool then moves home, and the spindle is turned off, and then the program ends. So simply you can write this to create this sort of program. Okay, so now let's look at it from the software, how it is simulated. Okay, so very briefly we can just do that and see how the software is simulated. So we go to the CAD viewer file, we create a new file.